What is going on, guys? Welcome back. In this video today, we're going to do a crash course on Postgres, the most popular, the most widely used database management system out there. It's a relational database management system. And I think that for a channel that focuses a lot on machine learning, a lot on artificial intelligence, data science, databases are like kind of the foundation. You need to know how to work with databases. So I think a lot of people maybe know how to program in Python, maybe know how to even build agentic workflows. But if you miss the database basics, that's not good. So today we're going to cover them. If you like this video, let me know by hitting the like button and subscribing. And now let us get right into it. Alright, so we're going to do a crash course on Postgres today. Now, as you probably already hear it, my voice is a little bit scuffed today. It's because I have a cold or allergies or something. I hope this doesn't distract you too much, but you can prepare for an occasional voice crack here. So Postgres is the most popular, arguably the most popular relational database management system. You could say it's the most mainstream one. When you start a new project and you need a database, you either go with Postgres usually, or you go with SQLite if it has to be very lightweight and you don't really need a lot of features. But Postgres is the go-to choice. It's the default choice. And I think there's multiple reasons for that. One of the reasons is it's open source, free to use. You can use it in every project without having to pay anything. Another reason would be it's super simple to get started with. It's beginner friendly. Also, one of the major reasons, in my opinion, is it has a ton of features. It's super extensible. Oftentimes, new databases are released that have specific features, and a couple of months later, you get powerful Postgres extensions where basically Postgres becomes like that database. An example would be PG Vector. Oftentimes you don't need a separate vector store. You can just use PG Vector. Now you have a column in your database that's a vector. And also, of course, Postgres is quite old already, so people just trust it. But we're not going to talk too much about the theory here. Let's get right into it. I think if you're learning databases, Postgres is probably the best way to get started. So we're going to make a crash course on this today. And let us start with the installation. How you install this, of course, depends highly on your operating system. If you go to postgres.org or postgresql.org/download, you will find the different installers. For Linux users, I recommend you use your package manager if you want to install it locally. These are all local installs. In this video today, I'm going to install a Docker version. If you're not familiar with Docker, if Docker scares you, if you don't want to use Docker, no worries, you don't have to use Docker in this video today. I'm going to show the setup. If you're not using Docker, just skip it, install it normally, use it on your system. If you want to use Docker, just follow the steps. The reason I'm using it is because it's just easy to set up and I don't want to install Postgres on my system. But just choose the operating system that you're using, choose the package manager that you're using, and install Postgres onto your system. So if you want to go the Docker route, pick a directory on your system. In my case, I'm going to go with the tutorial directory and create a new file called docker-compose-yaml. So of course, this assumes you have Docker set up on your system. Again, you don't have to do it. I'm not going to cover it here. I do have a Docker crash course if you want to take a look at it, but no necessity to use Docker here. If, however, you're using it, we're going to start with services and we're going to write the Postgres service. Postgres will be based on an image of Postgres. So we specify here Postgres-17, actually not dash colon. Then we choose a container name. Let's call the container PG-tutorial. And then we set the environment variables that are just going to be our username and password. So we're going to say Postgres_user is going to be equal to Postgres, then Postgres_password is also going to be Postgres. Of course, in production, you want to change this to actual reasonable values. And then Postgres_DB, it's automatically going to create a tutorial database. So let's just call this tutorial here. Then, of course, in order to be able to use this locally, we want to map the ports. Postgres is running on the port 5432. So we want to map this to the local port 5432. Like this. And important, if you want to persist what you're doing, we're going to say volumes, and we need to define a Docker volume down below then, and say that the Postgres database that we're working on should be stored even if the container vanishes. So I'm going to call this one PG data, and we're going to map var or /var/lib/PostgreSQL/data. Now, an extra thing that we're going to install on top, this is optional, but I'm going to show a lot of the tutorial in this tool, is pgadmin, which is a web interface that allows us to work with Postgres. You can also just use PSQL in the command line. We're also going to cover this today, but I want to show you both. So we're going to also install pgadmin. And of course, if you're not using the Docker Compose setup, you can also install pgadmin on your system as a separate tool. So the image here is dpage/pgadmin4. The container name here is going to be pgadmin-tutorial. And then we can set default credentials in the environment. So I'm going to say pgadmin default email, and we're going to call this, for example, admin@example.com. And then pgadmin default password will just be admin. Then we also want to map the ports here. Here I'm going to say I want to map 5050 to 80. And finally, we want to also say volumes, pg data, just to define that this volume exists. So that is our setup. If you're not using Docker, you probably didn't watch this, but this is how I'm going to run Docker, or I'm going to run Postgres and pgadmin using Docker here. So close this and then just go ahead and say docker compose up. This is enough to initialize or to run and then initialize the Postgres database or Postgres server with the database and also pgadmin. All right, and just to be clear what we're doing here, pgadmin is listening on port 80 and we mapped it to be on port 5050 just because 80 is oftentimes taken and we're using 80 for something else. So what we have to do now to access pgadmin is we have to go to localhost 5050. So localhost 5050 in your browser, and this is going to take you to the pgadmin web interface. Here now we can just enter the email we defined as an environment variable, so admin@example.com, and the password is admin. Now we're going to take a look at two tools to interact with our database. One is pgadmin. This is the user interface where you can click and look at stuff. And then we also have the command line tool, which is PSQL. Now, in order to have PSQL on your system or pSQL on your system, what you need to have is you need to have either Postgres installed and you have the tool automatically, or you have to install at least a library that gives you this tool. So if you're going with the Docker Compose setup where you have pgadmin and you have a Postgres running via Docker Compose, then you can do two things. You can go into the container itself. So we can go to the tutorial directory again, and here I can say Docker Compose exec, and then I can go into Postgres and run bash, and then here I can use PSQL. That is a possibility. I can just connect to localhost and use the tool from within the container, or you have to install the package that gives you the PSQL or pSQL command line tool on your system. So in my case, I used Pacman for this on Arch Linux, pacman-s, and the package was called, let me find it here in my prepared notes, Postgres or PostgreSQL-libs. So this gives you not Postgres as a whole, but just the libraries that contain also the CLI tool. So we're going to take a look at both, but first of all, let me show you pgadmin. Then we're going to also take a look at the command line. pgadmin is now the management tool here that we can do everything in a visual way in. And the first thing that we want to do is we want to connect to the server. So right now we have no server here, and we want to add a new server. And I'm going to talk about the terminology in a second here. What is a server? What is a database? What is a schema? What is a table? But for now, let's just accept that there is a server. That is our running Postgres instance, or Postgres instance that is running. And we're going to connect to it by first giving it a name. Let's say tutorial server or something like this. And then in connection, we have to specify now how we want to connect. Now, keep in mind, we're connecting here from within a Docker network. So in my case, since I'm running the Docker setup, I have to provide the host name of the Postgres instance within this container. If you're running this locally on your system, you would go with localhost. Since I'm not running this on my system locally, but in Docker, I need to say Postgres because this is what my container is called, or my container basically. So Postgres is the host of this thing, and then I have the username also being Postgres, the password also being Postgres, and the database is tutorial. So I can just save this here, and this now starts a connection with my tutorial server. So again, if you're not sure what you have to enter, go to your Docker Compose setup. If you used one, take a look at the Docker Compose file. In here you have the username, the password, the database. This is what we entered. And this here, Postgres is the host. This is the thing that it is called in the network. If you're running this on a server, you provide the IP address. If you're running this locally, you provide localhost. Just so you know what you have to provide here. So let us talk about the terminology. If you look at this here, we have a bunch of stuff. Especially as we go deeper here, we have a ton of things that might confuse you. You can ignore basically all of it for now. We're going to focus on the essentials. We have a server. The server is our running or our Postgres instance that is running. This is what the Docker container is running, the Postgres server. Now, a server can have databases. A database is just a way or a place to store data in an organized way. We can retrieve data, we can save data, we can do stuff with data in an organized and structured way. This is what a database is. And we have the Postgres database by default, and we have the tutorial database that we created by providing the environment variable that had the name. Now, in a database, you have a bunch of stuff, extensions, languages, publications, whatever. The important thing for us now is schemas. And a schema is basically a collection of tables, views, and a bunch of stuff that you don't know about yet. Triggers, for example, trigger functions, sequences, whatever. A schema contains all of this, and we can have multiple schemas. Schemas are usually focused namespaces, you could say. You have user schemas, you have post schemas in a blog, for example, order schemas in e-commerce. So you have different tables and views and triggers that relate to user management, different tables, triggers, and stuff that relates to blog posts, for example. And in schemas, the thing that we're going to focus on in this crash course are the tables. And tables are basically just structures, you could say, where we store data using rows and columns. So if you have a people table, for example, you would have the columns name, age, occupation, gender, whatever, and then the rows would be the individual people. So Mike, male, 30, programmer, something like this. So this is what a table is, and multiple tables make up, or not just multiple tables, but multiple tables in combination with all the other stuff that you don't know about yet makes up a schema. Schemas, you can have multiple of those in a database, and you can have multiple databases in a server. So that's enough of the theory now. Let's go ahead and do something. Let's create a table, for example. So for this, let's go and right-click here to Query Tool. So right-click Tables, go to Query Tool. There's also different ways to get there. And now we can just write stuff. And to write stuff, you need to write it in SQL, in SQL, structured query language. And one very simple thing that we could do is we could create a table for people. So I can say create. This is literally like English. Maybe I can zoom in a little bit so you can see this better, even though it doesn't look that good. Create table is just English. And the next thing is, what is the name of the table? The name of the table is people. And what I define next is I define all the columns. So create table people, then I use parentheses. I always have to close a command or end a command, a statement, by using a semicolon. And in here now I can provide the columns. So I can say every person has a name. Now the question is, what is a name? Or maybe let's call this person name because name is a reserved keyword. Person name. Or maybe let's do it like this. We're going to say first name and last name. And the question is, what is a first name? A first name is a string, a text, whatever you want to call this. In SQL, we say this is a variable character, a varchar, and we can provide a length. So let's go with 255. Now there is also char if you don't want to have it variable. This is just less flexible in terms of memory, but here we're going to go with varchar 255. That's enough for a first name. And I can also provide certain constraints. But for now, we're going to keep it like this. We have a first name, which is a text value. Then what I do is I provide a comma, and I say I also want to have, let's copy this, a last name. A last name is also going to be of the text type. Then maybe I want to have an age. That could be an integer. Then I could say I want to have a job. This could also be a variable character, 255. And then I might want to also say if the person is employed or not, which is not a very intelligent thing to choose here, but let's say employed is a Boolean. Now, one thing that we also want to add here is something called a primary key. And the primary key is the column that we use to identify individual users. So I can have a person with the same first name, last name, age, job, and employment status, but that doesn't mean that it's the same person. And to distinguish the people, I need a column that is unique, not null. So it has to always be set. It's always unique. And it has to be the identifier, which we can call ID here. And I can say ID is an integer. In this case, it's just going to be a number. And I can say primary key. This is going to make this the identifier of this table. So that is the most simple thing that we can do. And I can now just go ahead and execute the script by clicking this button, pressing this button. And you can see down here, query returned successfully in 54 milliseconds. So when I zoom out a bit again, we can see now if I uncollapse the tables, Hopefully, I don't see it right now, but I have to probably right click and refresh. And then if I go back to tables, we can see that we now have a people table and I have columns. So if I uncollapse the columns, we can see the different columns here. I can also right click the table, go to properties, and see everything here in a GUI interface. So I don't even have to type create table. I can just go and edit the stuff here myself. I don't need SQL commands to do that in pgadmin. But of course, what we're trying to learn today is SQL and Postgres as a database management system. So we're not going to use mainly GUI tools. We're going to type everything manually. And now this is our table for people. What happens if I try to run this command again? If I just execute the same script again, I'm going to get an error. Relation people already exists. But sometimes I like to have a script that I run from top to bottom and I want to keep the command in there. So what can I do here? I can use plain English. I can say create a table if not exists people. So create this table if it doesn't exist, otherwise just skip this. So I can run this and you can see already exists, skipping, create table, worked. Now what we can do with this table is empty. And if I want to see that this table is empty, I can use a so-called select command. There is a select command or a select statement in SQL that basically says select, then you choose the columns. If you want to choose all the columns, you use an asterisk. So this symbol here. So maybe we can maximize first so you can actually see the code primarily. If I say here select everything from is the second keyword. So I say select everything from a certain table, people. Then I use a semicolon, then I zoom out again and I run this. I have to, of course, minimize to see the result. Then you can see I get the columns, but I get no data because our table is empty. We don't have anything in our table. So selecting everything from the table gives us the structure of the table, but no content. So then, of course, we have another statement, which is the insert statement. Insert into tells us or allows us to insert data into a specific table. So insert into people. And then I can say values and I can provide in parentheses individual rows. So I can say in the right order, ID would be 1, for example. First name would be Mike. Second name would be Smith. Age could be 30. Job could be programmer. And then true would be the Boolean, the employment status. So this here is an insert statement. I can run only this statement by using this second execute query button. This only executes then the insert statement, not the entire script. And you can see now something was inserted. I can go and run the select statement now. And I have data in my table, which is Mike Smith, 30, programmer, true. So this is how we can do that. Now, before we go deeper into SQL and into the different statements that we can use, let me show you how we can also connect with a CLI tool. So not with pgadmin if you don't like the user interface. If you like to stay in the terminal, you can also use PSQL. So what do we need to do here? We need to just say -h and the host. Now, since we're connecting from the outside, since we're connecting from outside of the container, pgadmin is running inside another container. So we need to provide Postgres as the host. But I myself am connecting using PSQL to the Docker, Postgres instance where I have the port mapping. So I have to say localhost. And of course, if you're running Postgres without Docker on your system, you would also go with localhost. Then I say -U for the user. That's going to be Postgres. And then -D, which is going to be the database tutorial. I'm not providing a password because it's going to ask me for the password anyways. So here now I say Postgres, and now I'm connected using the CLI. And in the CLI now, I can do a bunch of stuff. I can run basic commands like \D to see all the relations and DT to see all the tables, in this case, the same output, but there's also other relations than just tables. We have views, for example. So here just \DT gives me the tables. I can also say -L to list the databases. Here I have Postgres, template 0, template 1, tutorial. And what I can also do in this command line, and by the way, if you want to clear the screen like I did it right now, you can just say \! and clear. This is going to run it as a Linux command. But what we can also do is we can just type SQL statements. I can say select everything from people, and we're connected to the same database, to the same server. So I can just run this and we'll get the data that I just inserted in pgadmin. And I can, of course, insert more data here using PSQL. So I can say insert into people, And I can say values. Let's go with 2. Let's say Lisa, and then, I don't know, Woods or something like this. And then we can say that she is 45 and she has the job clerk, and we can say that she's employed as well. And then semicolon, this is also going to insert. Now if I run select, I can also see all the data in the database using the command line. And of course, if I go back to pgadmin and I just run this line here, I'm also going to see the new row in my table. So that is nice. Now, I'm going to mostly be coding here in pgadmin just because it's easier to understand for beginners when you have all the colors and everything. So I'm going to be working in this here. But again, everything I do here, you can also do in the PSQL command line tool. So let us go back to our script now. I'm going to maximize. And here now we can also look at a different way to insert values into a table. Because right now we're taking every single column and we're providing values. And these values, of course, can also be none. So I can, or null in SQL. So I can say ID 3, I can say it's another Mike, but he doesn't have a last name. So I can just say null, which is an empty value, basically a non-existent value. I can also say he doesn't have an age. I can also say he doesn't have a job, but I can say he's employed, for example. That is possible. I can run this. And that's not a problem. We will see this entry in the database. If I minimize here, you can see we have Mike with null, null, null. So that's totally fine. However, this is not the best way to do that. What we can also do is we can specify the specific columns that we want to insert. So I can say insert into people. And then before I say values, I can use parentheses to specify columns. So ID is a must because I need to provide the primary key. I need to have a value for all columns that are defined to be not null. Even though it doesn't say not null here specifically, it does say it implicitly by saying primary key, because primary keys cannot be null. So ID, first name, and then employed, for example, would also work. Then I can say value, and I can just provide 4, and let's say John, and let's say true. So these would be just 3 values, and I can run this, and this will also be inserted, values, of course, plural. This will also be inserted into the database. If I now select again, you will see it's the same effect as before, just that we didn't have to type null explicitly. And this also allows you, of course, to reorder the arguments. So you can say first name and then ID. So we can do first name ID employed. That is also a possibility. I can say it's Bob, he has the ID number 5, true, and I can remove the 4 here. So that is also not an issue. This is however we define it to be. The only thing is you need to provide the values that are not null. And if you want to see how to make something not null, you just go to the column and you type not null afterwards. So in this case, or actually let's do it also for the last name, you will see that this will lead to problems if I run a statement like this. So if I go and say that this is Chris, for example, ID number 6, and I run this, you will see that this will result in, it will of course succeed because we still have our table. So we need to first actually make the change. For this, what we can do is we can drop the table before we create it again. So I can say drop table people. Drop table people basically removes the table. Everything is gone. If I execute this, the table does no longer exist. So if I run the select statement here, you will see that I get an error message that this relation does not exist. So what I have to do is I have to create it again, now with the constraints not null. So I can run this, and this will create now a new table, and I can do the same command that I did before with this Mike null null null, and you will see that this tells me failing row contains, because now the null value in a column which has a not null constraint. So the column last name has a constraint that it's not null, but we're passing actually last name. This is written in an odd way. So let me again drop the table and create it again, and then try to insert again. But now you see that this violates the not null constraint, and this as well. So if I run this, it will also give me a violation of the not null constraint because last name has to be set. Now, another thing that's interesting is that the ID always has to be specified manually. And it makes sense if the ID is something like an identifier that is a complex string, maybe has a structure in it, maybe is randomized, but oftentimes the ID will just be an incremental number. So it will be 1, 2, 3, 4, 5, and so on for every new user. In this case, int is not the best type that you can choose here. We want to choose something called serial. And serial is the way that you define this in Postgres. In other database management systems, you oftentimes call this auto increment. It's a constraint or a separate property that we attach to the column. And this just basically means that you don't have to specifically provide the ID. You can just say that the ID is implicitly given by incrementing the ID of the last row. So I can run this, or actually let me run this and then this. And now I can just go ahead and insert into people without providing the ID. So I can just say insert into people, for example, first name and last name. Even though the ID is a primary key and thus not null, I can say that I have Mike Smith, for example, without all the other values. And when I run this now, the ID will implicitly be given. So if I select, you will see that this is when I minimize, this is 1. And if I do it again, because we can have duplicate names, I'm just going to go and run the same statement multiple times. Then you will see that the ID automatically just increases by 1. So 1, 2, 3. Again, this makes a lot of sense if you're using just a number. If you're not using something like a social security number, that is a good way to define the ID. And by the way, you don't have to always just insert an individual row. You can say Mike Smith, and then you can open another set of parentheses here using a comma. So I can say Mike Smith, I can say Lisa, what did I call her? Woods. Then maybe we can say Chris Stones or something like this, making up random names here. Executing this, selecting, and you will see that all of these end up in the database. So we can also do it in a batch. All right, so now we know how to create tables, how to populate them, so how to insert data into tables. We know how to select from tables. We also know how to drop tables. By the way, if you want to make this conditional, you can also say drop the table if it exists. This makes sense because you cannot drop a table if it doesn't exist. So you can just type it like this as well. But now we want to move further and say, how can we select specific rows of data? So right now we're selecting all the rows, we're selecting all the columns. Of course, we can also say select just the first name and the age. This is also possible. I can do that. In this case, the age is null because we didn't insert any ages, but that will give me just these columns. But what if I want to say, give me only the columns that have an age value of above 30. So how can I do filtering here? For this, let us actually add some data that contains the age. So we're going to say Mike Smith, and I'm going to say that he is 30. Then she here is 45, and this guy is, let's say, 80. So now we have a bunch of age values too. Let's drop the table, or let's mark all of this and execute this. There you go. So now I can select everything again, and we see we have Mike, Lisa, Chris, 30, 45, and 80. Now the question is, how can I get, for example, all the people older, or let's say younger than 50? Now, in this case, all I have to do is I have to take the select statement I already have, and I have to attach a where statement. So select first name, age from people, where, and now I can type a condition. I can say that the age has to be less than 50. So I write this like this, and I use a semicolon to run this statement, and as a result, I get only Mike and Lisa. I can also say has to be greater than 50. In this case, I would only get Chris. But also we can do filters that are not just for numbers. So for example, maybe I want to say that the last name has to start with an S. So how would I do this? I can do this by using the like keyword. So I can say where last underscore name like, and then I have to provide in quotation marks here the pattern. The pattern is I want to have an S and then whatever, which is a percentage sign. So S% basically means S and then whatever. If I do this, I will get all the people that have a last name starting with S, which is Mike Smith and Chris Stones, even if I don't show the last name in the query. If I want to show it, I can just say last name like this, and I will also get it here. And of course, I can combine all of these as well. So I can say I want the age to be less than 50 and the last name to be like S%. So this means I want to have only the people that are younger than 50 and have a last name starting with S. So now I can run this and I will only get Mike. And if I'm interested in a logical or, not an and, I can also say or. In this case, I would get all of them because all of them are either younger than 50 or have a last name starting with S. So if I do this, I will get the full result set. Now, let us try something else. Let's say that I'm interested in the job of the people that have a certain age. And for this, I want to add the data and change the data. So I'm going to say here age and then job. And I'm going to say that Mike, for example, is going to be a programmer. Lisa this time is going to be an accountant. And then we're going to say that Chris is going to be also a programmer. And now instead of dropping the table, by the way, I can show you another thing. We can truncate a table. Truncating a table means that we're just emptying it. We're not removing the structure. We're not dropping the entire table. We're just truncating it. So I can say truncate table people. And if I run this now, this means that our data is gone. If I say select anything here, it's going to be an empty result set. So just like this, you will see there's no data, but the table still exists. So I don't need to create it again. I can just truncate it to empty it. And what I can do now is I can say I'm interested, or maybe for this, yeah, we can keep it like this. Doesn't really matter. Let's say I'm interested in the job of people. So select job from people where age is, let's say, less than 100 to cover all of them. Whatever query you get, you will sometimes get duplicates. So I will get, of course, only after inserting the people again. But when I do this, you will see that we get duplicates. We get programmer, accountant, programmer. And since I'm not combining this here with a name, I get duplicate information, programmer and programmer. If I don't want that, what I can do is I can say distinct. So I can say select distinct job from people where age is less than 100. And this will now give me every value only a single time. It will deduplicate the results. So accountant and programmer. Now I can also combine this now with the first name. So I can say select distinct job first name from people. And when I run this, you will see that now the deduplication does no longer work because now it's not the same statement anymore, or entry. It's not the same entry anymore because yes, it's programmer, but one is Chris, one is Mike. What else can we do? We can also do stuff like in between values. So I can say, let's remove the distinct again. Let's just go with first name and age. And I don't want to say that the age has to be less than 100. I want to say where the age is between, and I can say the age has to be between 32 and 67, for example. And when I do that, the only person that matches this description is Lisa with 45. So this is another syntax. Also for values like the job, I can do membership. So I can say where the job is in a certain list. So I can, of course, do equality as well. I can say the job has to be equal to programmer. That is the trivial example. And in this case, I get Mike 30, Chris 80, because both of them are programmers. But if I want to say that it has to be programmer or something else, I can also say in and provide the values in parentheses. So if I say programmer clerk, the result set will be the same because we don't have a clerk in a data set. Let's see if that's the case. There you go. But if I say programmer and accountant, then we're also going to get Lisa. And you can see we get Lisa as well. All right, so what do we know now? We know how to create tables, to drop tables, to empty tables, to insert data into tables, and to select in different ways, specific columns, specific rows based on conditions. We can also combine the conditions. So let us now talk about changing information, not just adding new stuff, but changing the value of a row in the database. We can do that using the update statement. So I can say update, and then a table name, people, and then what do I want to do? Set, for example, job equal to designer. And where do I want to do that? I want to do that where a certain condition is met. This can affect multiple rows. So if I say, for example, change the job to designer for every person that's less than 80 years old, then I'm going to change 2 rows here. If I say set job designer where ID is something, then I'm going to change a single row. So if I say that job is equal designer where the first name is equal to Lisa, then this is going to update that specific row. And if I now say, let's go with the select everything from people again, then you will see that Lisa now has a different job, which is designer. But as I said, if I say that, let's call programmer coder now, and I say that the last name here has to start with S, then this will affect the other 2. So if I say last name like, and then S%, This will affect the other two. So if I now run this, you will see we have designer, coder, coder. And finally, of course, we can not just add information, we can also remove information. So we can also go ahead and say delete from people, and then I can say where. Again, condition can be multiple rows, affecting multiple rows, or just a single one. I can say where ID equals 4, I think was Mike in the output right now. So if I run this, we should be able to see that Mike is no longer part of the table. We only have Lisa and Chris. So delete from, and then a condition. This can again be 500 rows. This will just delete the entries. But now let's go back, truncate the table, and start again with the data that we have, because now I want to show you another keyword that we can use in combination with select, which is order by. We can order the outputs by a certain column. So if I say, give me everything from people, and then order by, and then I can say order by age. So if I do that, all the entries will be ordered by age. So I have 30, 45, 80. Now in this case, it's also ordered by ID, so maybe you don't see the effect. So let's go and say by age descending, D-E-S-C. This would reverse the order. So if I say by age descending, we would have 80, 40, 45, and 30. Now I can also say order by job. This would be an alphabetic ordering. So now I would get accountant, programmer, programmer. And I can also order by 2 columns. So I can say first order by job, so I get accountant, programmer, programmer, but within the same job, order by age in reverse. So right now I have accountant and then programmer, programmer, but here you can see 30, 80. If I want to have 80, 30, I can say order by job, comma, age, descending. And if I do this, we would get the reverse order for these two. Another major statement is the group by statement. For this, I could say something like select job from people, group by job. This would not be a very useful query, but I can do that, and I would get just the jobs. But grouping makes most sense when you aggregate something. So for example, you cannot just say select job and then age. This would not work because you either have to aggregate or you have to group by. So in this case, you would get an error message. But what I can do is I can say, for example, count, which is an aggregation function, and I can just provide everything here, count asterisk. This would mean give me for every job how many people have this job. So if I execute this now, you would see accountant 1, programmer 2. Now, if I want to get a specific column involved, I can also provide it, but count doesn't make a lot of sense for age. So let's go with something like AVG for average. This would give me the average age of the person or of people by job. So in this case, the average accountant is 45 years old. The average programmer is 55 years old. And I can also do the same thing with max. What is the oldest accountant and the oldest programmer? In this case, 4580. What's the youngest one with minimum? In this case, 4530. So these are aggregation functions that we can apply onto individual columns. I can also combine this with count asterisk, so I can add as many of those as I want. In this case, I'm just grouping by job and I'm saying, okay, give me these values based or grouped by jobs. So we're collapsing all the people that have the job accountant, all the people that have the job programmer, and then we have the minimum age and the count here, so the number of people. What I can also do, and for this, maybe we should craft more examples like this. So let me maybe add, and by the way, we can also do this in separate rows. So let's do this like this so we have a better overview. I can now go ahead and just copy this just so we have some more data, and then we could have maybe people with the same age. Let's say John Stones, or actually let's give him John Smith, 80, and also programmer. So they have the same age and occupation, but different names. Then we could say Susan, also Smith, let's say, and she's 32, and an accountant. And then we could go with Bob, I don't know, Gates or something, and he is also 32, and he's, let's say, a designer. Now let's truncate the table again, run the insert statement, and of course don't forget the commas here, then run the insert statement. And now if I do that, first of all, we get more data to look at, as you can see. But now what we can also do is we can group by multiple columns. So I can not just say group by job, I can say group by job and then group by age. So I can run this and I would get the combination. And for this, I should also provide age here as a column that I'm selecting. But you would see now that, and of course now the minimum age doesn't make a lot of sense. So let's go just with count. This would show us that we have one accountant that is 32. We have one accountant that is 45. We have one programmer that's 30. We have two programmers that are 80. And we have one designer that is 32. Now I could also group by last name if I want to. So I can say last name, and the column here is also last name. Run this, and you would see that I have two programmers with the name Smith. And then for these, I could also get the average age. So that would make sense in this case to see the average programmer with the last name Smith is 55 years old. And there's also a special statement that we can add at the end of this to have a condition. So for example, give me the job, last name, average age from people, group by job and last name, considering the condition is that they have at least a count of 2. So that the count of asterisk has to be greater than 1. In this case, we would only get those where it actually makes sense. This would just be a single row, programmer, Smith, 55, 2. And by the way, if you don't like the way this is displayed, like average or count, you can also go ahead and give it an alias. You can just go select job, last name, average, and then you can say as average age, and then count as whatever, like number of people or something like this. So I can just run this, and in the output, I would get different column names. And then one more thing before we move on to the next category of commands. One simple thing that we can also do is we can limit the amount of rows that we get back. So if I do something simple like select everything from people, just run this. This will give me all the rows, and I can also limit that if I want to. I can say give me all the people, but give me a limit of 3, which of course makes sense with the ordering. So if I do it like this, it makes also sense to say order by age, for example, and then I would get the top 3 youngest people. Or if I say descending, I would get the top 3 oldest people in the database. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. Okay, so at this point, again, we know how to create tables, how to drop tables, how to empty tables, how to insert data, select data, change data, delete data, and how to do fancy queries with grouping, with ordering, with filtering, and all of that. Now we want to talk about changing the table structure. So once a table exists, how can we change it? This is not the same as updating, because updating is updating the data in the table. Altering a table means changing the columns, changing, for example, the data type or the constraint. And this is done using the alter commands. So I can say alter table, and then people, and I can say what do I want to change. For example, add column. And then I can add a column that contains the height, and this should be a decimal 10.2. By the way, for data types, I have a link for you guys. I don't want to cover all of them here in theory, so I'm going to go to my prepared code. I have a link. You will find it in the description down below. Here you can see all the different data types. So decimal PS is basically for precision and scale, and it's just a floating point number, but here you have an overview of all the different data types that you can use. I don't want to cover them now here. Just know that this is for text, this is for integers, booleans, serial for auto increment integers, and decimal is for floats. But doing this now would add the column to the table. So if I again select everything from a table, we would see that we now have a new column height, and height is null because we don't have values in there, but we do have the column now. And likewise, I can say alter table people drop column, and then we could use the employed column because we're not really using it. So drop column employed, and that would return success. And if I now select, we don't have this employed column anymore. And now is where things become really interesting, because let's say I don't want to just model people in a database. I want to model the ownership of things by people. So I have things, I have people, and people can own things. How do I do that in databases? Now, of course, a trivial, stupid way to do that would be I just add to every row here the stuff that they own. So I have, for example, a new column, thing 1, thing 2 or something. But of course, this doesn't make a lot of sense to keep track of all the things in the same table where I keep track of the information for a person. It's very messy and it doesn't even work properly. So what we do in databases is we create a second table for this second type of thing. So for the things in this case. So let's go and say create table things and then define it to have also an ID. Let's say this is the thing ID. That's going to be serial and also the primary key of the thing. And then maybe the thing can have a name, let's say thing underscore name. And this thing name is of type variable character 255 and not null. It has to have a name. Now, what we can also have, by the way, I didn't show you that constraint. We could have something like inventory number, and I don't want to use this as a primary key. I want to keep my ID, but I still want it to be unique. So I can say the inventory number can be null. It doesn't have to be there, but if it's there, it has to be unique. So I can say this is a variable character. Even though it's a number, we can say it's a string number, and I can say unique. And then let's say we have description as well, and this is a variable character 255, but it can be null. Now, how do I model the ownership? How do I say that a thing is owned by a person or a person owns a thing? Now, there's basically 3 ways to do that. One is I go to the people table and add a new column thing. I say that a person owns a thing. The problem with this is a person can then only own a single thing. So it doesn't make a lot of sense because people can own multiple things. So I could say thing, or I could say thing 1, thing 2, but that's also, again, as I said, messy, doesn't make a lot of sense. So the second idea would be to add to the thing an owner. And this is what we're going to do here in the first step. We're going to say a thing has an owner. Everything has to be owned by somebody, or it doesn't have to be. We can say it's nullable. We don't have to force it by saying not null, but a thing can have an owner. And then you also have the scenario where a thing can be owned by multiple people. In this case, you would have a many-to-many relationship, and in this case, you would need a separate table for ownership. So a new table where you match things and people as owners and owned thing, so to say. But we're going to start with a simple one-to-many relationship, one-to-n relationship. So we're going to say item owner is an integer. Now, why do you say that this is an integer? Why don't we say that this is a person? Because we're not in Python here, we don't have classes called people or person. We cannot just use them as an object or as a class definition here. We need to define this to be a so-called foreign key. So the primary key is what identifies your table or the row in the table, and the foreign key is the primary key of another table that I'm connecting to. So I could say item owner int, and I can either say here directly references people and then ID. That would be possible, but if you want to have more control, you can also define a specific foreign key constraint. By the way, constraint, we talked about unique and not null. One more thing that I want to show you here is we can also have check constraints. So I can say I have a price, for example, decimal 10.2, and I want to add a constraint check that the price has a certain condition that it fulfills. So for example, I could say the price has to be greater than or equal to 0. So it cannot be negative. But yeah, so you can either do it like this, item owner references people ID, or we can say item owner int and create a constraint, a foreign key constraint manually by saying constraint at the end of the column definition, constraint FK for foreign key item owner, foreign key item owner, and then references people ID. So that's fine as well. And by doing that now, we are connecting these two tables. So I can actually create this table and see if this works. Query returned successfully. And now I can add some data to the table. So to keep this simple, I'm going to just copy paste this here as before, insert into things. And now the columns that we want to insert, inventory number, thing name, price, and item owner. And here I just add some random strings. some names, some prices, and the owner ID. So I have person 1. I'm not sure if I even have person 1 because the serial ID resets. So let me check if I have 1. I don't have 1. So let's go with 10 and 11 instead. So I'm going to go and say that this is owned by 10 and this is owned by 11. And now I can insert that data and we can query across tables. So I can say, first of all, of course, select everything from things. That is nothing new. That's the same as before. We just get the data here. But now I can also say that I want to connect these two tables. And I'm going to show you how this is done properly, but I want to first show you the old way of doing this because we're doing this with something called a join. We're joining the two tables, and the old syntax for this is not the one that you should be using, but it's the one that probably makes sense intuitively considering what you already know. So I can say, for example, select everything from people and things where, and then I can match the two columns where I can say where people.id is equal to things.item owner. So I'm just saying this is the same thing, match on these columns, and then give me the result. And this will in fact give me Mike Smith owning a laptop and a book, and then Lisa Woods owning a pen. That is what I get with a join like this. However, as I said, the syntax is outdated. What we do nowadays is we explicitly say that this is a join. So the clean way to do this is to use where only for filtering statements, like the price has to be below 500, and the join for the actual joining of the table. So I'm going to say select from people, join things, and then on people ID is equal to things item owner, and then I can still say where something is the case. But for now, let's just do it like this. Actually, like this, execute query, and you can see, again, I get the same result. And if I now add a where statement, I can say where the price, so the thing dot price is less than 800, because one of them is 900, so we're not going to see the laptop here anymore. And of course, it's things dot price, not thing dot price. So like this, and you can see we only get the book and the pen. And the join that we're doing here is actually an inner join, so you can say it explicitly as well like this, which means that we're only showing the columns where we have a people ID and an owner. We're not showing all the people, we're not showing all the things, we're showing only the columns where we actually have a match. So inner join works like this. If I run this, we will see the exact same result as before. There you go. But I can also do something like a left join. A left join means I take the left table, the people table, and show all the people even if they don't own things, but I also show the thing information. And for this, we need to remove the where statement so that we don't have the condition. Otherwise, we're filtering all the null values. But if I run this now, you can see what this does. It gives us all the people, Mike, Lisa, Chris, Bob, John, Susan, even if they don't own anything. And it joins the tables still. So we still have the thing information for those where it exists. We see them here, but for the other ones, we just get null values. I can also do the opposite. Now, in this case, it doesn't make sense because I don't have any rows, or maybe I should create some. Let's go and insert into the table an item. Let's do something like this. And let's say that this is a chair or something and has a price of 100 and it doesn't have an owner, so I provide null here. In this case, it would not be shown in an inner join, but if I say right join, I would get the item even though it's not owned by a person. You can see null, 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 but I get the information for the chair. And if I want to have both, I can go and get the complete picture by saying full join. This gives me from both tables all the rows regardless of matches. So I see all the people and I see all the things, and even the null values are shown. Now, there's one more thing I want to cover here, but before we do that, let me also show you the constraints that we have here that they actually trigger. So if I try to insert something with the same inventory number, this should fail. So it was this one. If I run this, I should get a problem with the constraint here, duplicate value, even though we have the unique constraint. And also if I try to enter a price, let's say I use a proper ID like J here. And if I try to enter a price -100, this should also fail because I have a constraint that checks whether the price is positive. So this works. Now, the last thing I want to show for this crash course today is how we can model an N-to-M relationship, so a many-to-many relationship, because a person can own multiple things and a thing can be owned by multiple people. So what I'm going to do now is I'm going to say here, drop table if exists things. So we're going to get rid of all the things that we have, and we're going to create the table again, but this time without an owner. So just like this, simple table, simpler than before. And now I'm going to create another table called ownership. Create table ownership, which contains the owner. So I can say item owner, and that is going to be an integer, which is going to reference, so references people ID. And then I'm going to say there's an item, and that's going to be an integer, references things ID. And then this is now new. The primary key is going to be both of them. So the combination of item owner and item is going to make the unique primary key. So I can do it like this, execute query. And now to symbolize, or now to say that we have an ownership, let me create the things here. I can now say that I have some items, and I want to say that certain people own items. So insert into ownership. Actually, I should have called this ownerships to be consistent, but I called it ownership, so let's keep it like this. And now I would say values and just the IDs. So person, let me see what the current IDs are, because they always are different due to the serial data type. So I'm going to say select from things. We have here nothing. So didn't I run the insert statement? Let's see. Oh yeah, I'm still showing the item owner, so I need to remove that. So I'm still providing this as a column here. Let's insert, and now let's see what the IDs are. They should be 1, 2, 3. There you go. For the things, it's 1, 2, 3. And for the people, it's probably still 10, 11, and so on. So there you go. And now all I have to do for the ownership is I have to say that the person 10 owns the item 1. And then I can say also the person 11 also owns the item 1. But the person 10 exclusively owns the item 2. Person 12 owns the item 3. And then person 13 also owns the item 3. And that's it, for example. So I can just insert these values into ownership. This worked successfully. And now the join is basically the same. So I can say here, select P for people dot, let's go with first name, P last name, for example, and then thing dot thing name, and then T dot price from ownership. So I just select from ownership. And now I do the join statements. So I'm going to do this line by line. I'm going to say join people P on P.id is equal to ownership dot item owner. And then join things T on T.id is equal to ownership dot item. And that will give us now all the information that we need, everyone who owns what. And this is how you do proper joins across multiple tables, how you do a many-to-many relationship. So to recap, we now know the basics of Postgres. You know how to drop tables, you know how to work with the different tools here, how to create tables, truncate tables, insert data, delete data, change data, alter table structure, work with multiple tables. You know how primary keys work, foreign keys work. This is the basis that you need. And if you like this video, let me know in the comment section down below. Like the video, support it, because if you like this, if this video does well over time, I'm going to make an intermediate version where we go into views and triggers and everything. And if this video also performs well, I'm going to make an advanced one where we go into query optimization and all that. So it depends on you guys. If you give positive feedback, you're going to get deeper into this. Otherwise, that is a crash course for beginners. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services section and a tutoring section. There you can contact me if you need help with a project, a consultant, a freelancer, or something like this. Contact me at the bottom of the pages via LinkedIn or email. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.